All right, today we're going to look at the notes for 5-2, which is called Comparing Rational and Irrational Numbers. So what we're going to do is we are going to approximate irrational numbers, okay? And we're also going to compare and order both irrational and rational numbers. So we're going to put them in order either from smallest to biggest or biggest to smallest. All right, so square root of 3 is what we call an irrational number because it goes on forever and it doesn't repeat. So if you were to type into your calculator second and then x squared and then type in 3, so second x squared 3 and hit enter, we get a number 1.732508. Your calculator may give you one or two more numbers, but it says explain where root 3 would be in relation to the estimates of 1.7 and 1.8. So if I put 1.7 on the number line and if I put 1.8 on a number line, where would 1.73 be? Well, I know right in the middle would have to be 1.75. So that means 1.73 would be a little bit closer to 1.7 than 1.8. It has to be smaller than 1.75, which would be right in the middle, but it's got to be closer to 1.7 because it's less than halfway through. All right, so the next one says, find examples of a rational and irrational number between 4.8 and 4.9. Now, I always like to think money. So 4.8 is the same thing as 480, right? We could just put a 0 at the end. And 4.9 is the same as 4.90. Okay, so remember, a rational number is a number that terminates or repeats. So if I wanted to come up with a rational number in between $4.80 and $4.90, I have a bunch of choices. I could do 481, I could do 482, I could do 483, 84, 85. There's a bunch of numbers that I could do, okay? I could also do a repeating number if I wanted to. So I can go 4.83 with the bar on top, 4.83 repeating, or 84 repeating. So there are many options in between those, okay? So the only problem with irrational is irrational means that it doesn't repeat and it doesn't terminate. So I still need a number between $4.80 and $4.90. So again, we can pick 481, 482. The only problem is we can't stop there. I have to add a bunch of just random numbers, 3, 2, and then I'm going to go dot, 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 because remember, it can't stop, nor can it repeat. But the key is that 481 is in between 480 and 490. Okay, I could have picked 482. I could have picked any numbers in between 80 and 90. So it'd be 4.86, 4.87. But the key is that those numbers have to keep going forever, cannot repeat, and cannot stop. So just that dot, dot, dot at the end works perfectly. So if I asked you to come up with your own numbers, there is no way that you guys will pick the exact same numbers. There are so many different rational and irrational numbers in between a set of numbers. All right, so we're going to do the same thing here. So we've got 2. So I'm going to think of that as $2. And I'm going to think of 2.1 as $2.10, right? So money always makes more sense. So why not think about things in terms of money? All right, so we've got to come up with a rational number between $2 and $2.10. Okay, so I'm going to pick 2.07. Do you agree that that's between $2 and $2.10? Absolutely. You could pick 2.05, 2.06. We can even do 2.055, right? Because 05 is still between $2 and $2.10. And then if I add one more 5, that number stops, right? It doesn't go on forever. Now I could also do 2.05 with the bar over it. Because remember, that would be 0.5 or 2.05555555. And a repeating decimal is an example of a rational. All right, if we want an irrational number, again, we've got to still go between $2 and $2.10. So I could go 2.0, I'm just going to say 2, but I can't stop. So I just have to add a bunch of different numbers. So it doesn't matter what numbers you pick. I can pick 6, 7, 4, 5, 3, 1, and then I'm just going to put that dot, dot, dot. The only thing that can't happen is those numbers cannot start to repeat. Okay, if I want to come up with another irrational number, I can pick 2.0 instead of between $2 and $2.10. I could pick 2.08 or 2.09 or 2.07. And then again, all I have to do is add a bunch of numbers, 6, 4, 1, 3, and then that dot, dot, dot to show that it goes on forever. All right, so let's do the same thing with 5.3. So I'm going to think of that as $5.30 and then $5.40. So this time I'm only going to come up with one rational and one irrational because I'm hoping by now you get the idea. So one rational number could be $5.35, right? 5.35 is between 5.30 and 5.40. Okay, if I want to use that same number, I could go 5.35, but then I can't stop. I have to keep going. I could go 1, 4, 7, 8, 9, 6, and I just made up a bunch of random numbers between 1 and 9, but then we got to put that dot, dot, dot at the end. So if you take a look at the first three digits, 5.35, that's between 5.30 and 5.40. We could have picked 5.36, 5.37, 5.38, and so on. All right, the last one we're going to look at on this page is $10.60 and $10.70. So again, if we're looking for a rational number, it has to terminate or it could repeat. So between 1060 and 1070, I'm going to say 1064. Why? I just picked a random 64, 65, 66, 67, 68, 69. It doesn't matter. Okay, and then an irrational number would be 10 point, and I'm just going to use that same number, 64, but then I got to add a bunch of numbers, can't make it repeat or can't make it stop. So I could go 3, 1, 6, 7, 4, 9, and dot, dot, dot. It doesn't matter how many numbers you give me, but give me 5 or 6 before you start going dot, dot, dot. All right, so those are examples of rational and irrational numbers that are in between two different values. All right, so the next thing we're going to do is we're going to order numbers from least, which is smallest, to biggest, least to greatest. All right, so we've actually talked about this before, and we've done this before, just not with irrational numbers. Okay, so we have to figure out some decimals. So the first thing I have to do is I have to type in square root of 71 to my calculator. So if I go second x squared 71, that is 8.42614. And I think that's enough numbers because the other numbers only have one decimal place. All right, I also have to do the same thing to square root of 34. So I go second x squared 84, and that's 9.16515. And there's more numbers, but that's plenty. Okay, so if I take a look at the whole numbers, okay, my first whole number here is 8, 9, 9, and 8. Well, I obviously know that the two 8s have to be the smallest. Okay, so what I have to do is now I have to go to the next number. So now I go to the 4 and the 1. Well, 8.1 is definitely the smallest. 8.4 would come next, but I'm not going to call it 8.4. I'm going to call it what it was originally called, which was square root of 71. Okay, now I look at my 9s, right? My 9s have to come next. So if I look at my 9s, this is 9.3 and this is 9.1. So I know 9.1 is smaller, so that means root 84 has to go next. And the biggest number in that group is 9.3. So we've got to make sure we change all of the roots to decimals, and then we can compare those numbers. All right, we're going to do the same thing with these, writing them from least to greatest or smallest to biggest. All right, so the first thing we're going to type into our calculator is square root of 16. But when we type in square root of 16, you might be surprised. That's 4, right? 4 times 4 gives me 16. There's no decimals. So then I got to go square root of 14. And square root of 14 is 3.7416. I think that's enough. And then it does go on after that. So it's irrational because it doesn't stop and it doesn't repeat. All right, so notice that I have numbers. I have a 4, I have a 3, a 4, and a 3. So I know my 3s are the smallest. So looking at my 3s, I have a 3.7 and a 3.6. So this time 3.6 is the smallest. 3.7 would be next, but that was the square root of 14. So we're going to call it square root of 14. And now I have 4 and I have 4.1. Well, there's no decimals on 4, right? It's 4.0. So I know square root of 16 needs to be the next smallest because it's 4.0. And then 4.1 would be the next largest or the largest one in that list. All right, same idea for letter B. This time the numbers get a little bit bigger. So if I have to do second x squared and type in 150, and this one I get 12.247, and that's enough. I don't need any extra numbers. Then I've got 12, 11.8, And then in my calculator, I got to go second x squared and then 135. That gives me 11.6189. All right, so again, we're going from least to greatest, or smallest to biggest. So if I look at my numbers, I've got a 12, an 11, and an 11. So I know those last two numbers have to be the smallest. After the 11, I've got a 0.8 and a 0.6. So that means the 0.6 is smaller. So that means square root of 135 is my smallest number. 11.8 is my next biggest number, or next smallest number. And then if I look at my 12s, this one has 12.2, and this is just 12. And remember, we can write that as 12.0. So between 2 and 0, 0 is the smallest, so 12 goes next. And then square root of 150, which was 12.2, goes last. That's the biggest number. All right, taking a look at the last one like this, we have pi. So I don't know if you remember pi, but pi is a number. It's 3.14. You guys use that in middle school when you talked about area of circles. Pi is usually associated with circles. All right, then we got to type into our calculator square root of 6, which is 2.449 plus some extra stuff. I've got 3.4, which I don't have to plug into my calculator. And I got square root of 14 again, which is 3.7416. And again, that's enough decimals. So if I compare my whole numbers, I've got a 3, a 2, a 3, and a 3. So that means that 2 has to be my smallest. So root 6 is my smallest. Now when I look at the 3s, I've got to go to the next number. I've got a 3.1, a 3.4, and a 3.7. So 3.1 is the next smallest, so that's got to be pi. And then I've got a 4 and a 7, so 3.4 is next smallest. And then the biggest number is square root of 14. So I just put those numbers in order from smallest to largest, or least to greatest. All right, so then we need to take a look at greater than or less than. Remember, we talked about this last week. We said the alligator always has to eat the bigger number, so the mouth opens toward the larger number. And in order to compare numbers that are different, 2.5 is a decimal, we got to go ahead and plug in root 10 into our calculator. Well, square root of 10 is 3.16. So if I look at my whole numbers first, I've got a 3 and I've got a 2. Well, I know 3 has to be bigger, so again, that mouth on the alligator has to eat the root 10 because it's larger. Taking a look at the next one, I know 7. I can also write it as 7.0 if I wanted. And then when I plug in square root of 50, I get 7.07. So 7 is the same as $7. So again, if I look at the first number, the 7s are the same. If I look at the second number, the 0s are the same. If I look at the third number, I've got a 0 and a 7, so $7.07 has to be bigger. So the alligator has to eat the root 50. All right, if you forgot how to do cube roots, remember we have to press the 3. And then we press second, and then we press the arrow, and then we type in, 8 or 9 or whichever number we're looking at. So we're going to go 3, and then we're going to go second, the arrow, and 8. And that actually gives us a nice number. It gives us 2. All right, now if I go ahead and I go 3, and I go second, and I go arrow, but this time I plug in 9, that gives me 2.08. Okay, so again, this is the same as $2. So if I look at the 2s, right, 2 and 2 are the same, 0, 0 are the same. But now I look at my 0 and my 8, and the 8 has to be larger. So the alligator is going to eat the cube root of 9. All right, last problem involves 2 square roots. So we got to do square root of 110, which is 10.488. And then I got to do square root of 66, which is 8.124. And again, that's pretty easy. If I'm just looking at 10 and 8, I know that 10 is much bigger, so the alligator has to eat the larger number. All right, I'm going to go ahead and skip these last 2 examples because I feel like we have done enough. Go ahead and give the homework a try, and we will take a look at it tomorrow. Thanks.